what I'm going to do is that xy term, I'm going to rewrite it so that I can use substitution. So I'm going to rewrite that as y equals 4 over x. Okay, and then I'm going to replace that into the second equation. So 2x squared plus, and this I'm going to square it. So 4 over x. So that's 2x squared plus 16 over x squared equals 18. And then we've got it sort of fractions problem that we need to correct, at least get rid of the fraction. And so one of our techniques from earlier was to multiply by the denominator. So I'm going to do that. So I'm going to multiply both things by the denominator. And what that will give us, that'll give us 2x to the fourth. Now in that second fraction, if I divide and multiply by the same thing, they cancel each other out. So I'm left with 16 plus 18x squared. Okay, so that's what I now have. So I come over, I'm sorry, equals, should be an equal sign there, apologize. Okay, so then I'm going to bring the 18x squared over. So I have 2x to the fourth minus 18x squared plus 16 equals 0. And first off, I notice that I can factor out a 2. And that'll give me some smaller numbers, and smaller numbers are nice. So we always like those. And then this actually is factorable. So we get x squared and 8 and 1. So minus minus. Okay. And since we're solving this in this equation, then I'm going to take each of those and set them equal to 0. Alright, so this is going to be x equals 1, and that's x squared equals 8. Sorry, and when I take the square root, I actually get plus or minus 1. So that means I get plus or minus 1. So I get two numbers for that side. And over here, when I take the square root, I get plus or minus the square root of 8. And if you remember, square rooting is 2. 8 is 2 times 2 times 2. I have a pair of numbers, so I'm going to take one of those out. So I get plus or minus 2 square root 2. Okay, so in total, I actually have 4 x values, which means I'm going to have 4 corresponding y values in this graph. Okay, so we're going to just do them independently here. So when x is 1, I get y equals 4 over 1, so I get 4. So 1 comma 4 is a solution to my to this system. Then we get x equals negative 1, and so y equals 4 over negative 1. Gives me negative 4, so negative 1 comma negative 4 is a solution to the system. Then we have x equals positive 2 square root 2. So y would be 4 over 2 square root 2. And the 2 divides into the 4, so I get 2 over square root 2. And if you recall, we're going to rationalize that, so multiply by the square root of 2. So I get 2 square root 2 over 2, which is a fancy way to divide out the 2's. I get square root of 2. So another one of my solution points is 2 square root 2 comma square root 2. And then last but not least, we got the negative. Now the nice part here is we already did all the work, so we know what's going to happen. We should get a y that says negative square root 2. So a lot of symmetry going on with this one. Ordered pair of negative 2 square root 2 and a y value of negative square root 2. So we end up with 4 solutions, if I can get a box around all that. And there they are. So anytime you're dealing with that xy term, you're going to want to set up a substitution like I did here. All right, our next topic is graphing linear inequalities. An inequality in two variables, x and y, are satisfied by an ordered pair when x is replaced by a number a and y is replaced by a number b, a true statement results. The graph of an inequality in two variables x and y consists of all points x, y whose coordinates satisfy the inequality. Okay, so in other words, our picture is not going to look like a line, it's going to look like a shaded region of some type. So our first task in graphing an inequality is to figure out where to get some ordered pairs in it that we can actually plot points on. And a nice easy technique is to find the intercepts first. So for a brief moment, we're going to pretend that this is an equation, and we're going to find the intercepts. So the x-intercepts look like some number x comma 0. So it looks like some number comma 0. So in other words, replace y with 0. So we get 3x equals 0, so x is 2. So that means it crosses the x-axis at 2. And then the y-intercept looks like 0 comma some number, which means I replace the x's with 0 and solve, and I get y equals 6. So very quickly, I'm able to find two places where it crosses the x and y axis, and since it's a straight line, I can actually plot that. Okay, so our third step is to graph the borderline for the inequality and indicate whether it's solid or dashed. So set up a coordinate plane here. I know my graph crosses at 2 and it crosses again at 6. So I'm going to label some points there. And then there's this discussion about solid versus dashed. Okay, so if you don't recall this, less than or greater than, those all are dashed lines. When they do less than or equal to or greater than or equal to, it's the or equal to part that makes it solid. So looking at our original inequality, we had less than or equal to 6. So I'm going to put a solid line theoretically between those 2 points. And so that's what the borderline of my graph looks like. And then the last part is to decide whether I'm going to shade above the line or below that. The way we go about doing that, let me get the inequality back here. So 2x plus y less than or equal to 6. I'm going to pick a test point, something that's clearly not on the line. It's either one side of the line or the other. And 0, 0 is a really nice point if I can get away with using it. Sometimes it's on the line, so I can't use it, but then I just pick another point that I happen to know is not there. So when I evaluate this at 0, 0, either I get a true statement or a false statement. So here, 0 is less than or equal to 6. Well, that's actually true. Okay, so going back into my graph then, I tested it at 0, 0. I got a true value, which means that point is in the shading. So if it's in the shading, that means I got to shade wherever that point's located. So I'm going to shade below this particular line. And so that would be the solution to that particular inequality, is anything below the line that I graphed. All right, so looking at each inequality independent of each other, so we're going to do this sort of simultaneously at the same time. So looking at x plus y is greater than or equal to 2. So first task is to find the intercepts. So if I essentially put a 0 in for each variable, I get x is 2 and y is 2. And so we'll come over here and put some points. And since it's greater than or equal to, that means it's going to be a solid line between those two ordered pairs. And I'm going to do a quick test point to see whether I'm going to shade above or below. And it turns out 0, 0 is a good option for that one. So I get 0 plus 0 is greater than or equal to 2. And that's actually false. Okay, so since it's false, that means I'm going to shade away from that particular line. So I'm just going to label which direction I'm shading, because I'm going to include a second line here in a moment. So in that bottom line, I get 2x minus y is less than or equal to 4. So we'll do the cover-up trick again. So here if I put a y as 0 in for y, I get 2x equals 4, so I should get 2. And here I get y is equal to negative 4. So going over to my graph, I get x is 2, and then I get y is negative 4, so 1, 2, 3, 4 down there. And this one is solid as well. And let's try the origin again. So 2 times 0 minus 0. And that time I get 0 is less than or equal to 4. So I actually get a true statement, which means it is shading towards the origin. So it's going to shade above that particular line. So then I want to look at where do the two places overlap. So I can see very quickly that it's in between. It's the top part of our x, I guess. And so that shaded part would be the solution to that particular system. Okay, in the next example, same process. So first, figure out where it crosses the x and y axis. So if I find the intercepts, plug a 0 in, sorry, evaluate it at 0. So I get x equals 2 and y equals 2. So same as last time. I meant to do that. And it's less than or equal to, so I get a solid line right through there. And I'm going to test at the origin again. So 0 plus 0 less than or equal to 2, and that gives me a true statement. Okay, so that means I'm going to shade below the line that I drew. And then, so we go to the other one. Okay, so this time I got a slight problem. When I do the intercept method, I get x equals 0, and I also get y equals 0. So, okay, I know then that it goes to the origin. But I need to have 2 points. So at this point, sorry, at this time, let's take a look at this equation in slightly different eyes. Because I'm trying to figure out where does x plus y, where else does it equal 0? Just so I can get another ordered pair on that. So one very easy technique that I can do is I can just think of some ordered pairs that satisfy that. So for example, I'm looking at adding two things that equal 0. So if I let x equal 1 and y equal negative 1, add that up, that'll cancel out. X equals 2 and y equals negative 2. So I've got 2 points then. So 1, negative 1 there, 2, negative 2 there. Well, what do you notice? It looks like they are parallel to each other, which is actually what it is. So I've got 2 parallel lines. Now, the concern this time is that I can't use the origin to test it because 0, 0 is actually on the x plus y line. So I just need to pick a different point. And any point will work. So let's try so x plus y greater than or equals 0. Let's try 1 comma 1, which is clearly not on the line because 1 plus 1 is something else. So 1 plus 1 greater than or equal to 0 gives me 2. Okay, so that's actually true. So I can say that they would shade towards that particular point, so it would be a shaded above. And so what do I notice? I notice that these 2 parallel lines, I get this nice region between them, sort of this little strip between the 2 lines that happens to be shaded. All right, in this example, start with the same idea of finding intercepts. Sorry, I want to be consistent with my colors here. Okay, so in the top equation, if I solve for it, so replace each variable with 0 and solve. So I should get x equals 2 and y equals 1. So 0, yeah. So x plus 0 is 2, 2y equals 2, divide that, you should get 1. Okay, so means it's going to cross there and there. And the symbol tells me that it's a solid line. And if I'll test it at the origin, so I get 0 plus 2 times 0 is less than or equal to 2. And that actually is true. So that means I'm going to shade below. And then we'll do the same technique to the other equation. So x equals 6 and y equals 3. So again, replace x with 0, replace y with 0, and solve. That's where we're getting these two numbers from. So let's see, so 2, 3, 4, 5, 6, and 1, 2, 3. Okay, so we get another set of parallel lines here. And we'll test point this line. So I can use 0, the origin again. So 0 plus 2 times 0 is greater than or equal to 6. So I get 6. 0 is greater than or equal to 6. That's actually false. So that means I want to shade away. Okay, so now we've got a concern that we've got two lines and they're shading away from each other. I'm supposed to graph where they overlap. So in this particular case, they don't overlap. So there's no solution for this one. There's no ordered pair. There's no set of points that would satisfy both inequalities. So there's just nothing in common.